The 6-1 to 6-3 review. Calculators are not allowed on this portion, and we're looking at number 1. In all three of these, we are given a function that has two variables in it. We have the normal x, and then we have the second variable k. And our job is to figure out what k is if the area that is created in the fourth quadrant has a value of 108. So that means we need to know what the general shape of these curves are each going to look like. One of the ways that we can think about this and how it looks is we can deal with the fact that it is a parabola and it opens up and we're supposed to get area in the fourth quadrant. So because of that, that means that this is going to dip below the x-axis. So if we can figure out what the x-intercepts are, we'll have a better chance of graphing it. So if you remember from your Algebra 2, we can find x-intercepts by factoring. If I pull an x out, then I can set that equal to 0 and see that x will either be 0 or x will be 6k. Now we don't know what 6k is, but we do know that k is positive. So if we multiply by 6, it's going to be larger than 0. So that means on our picture, we have an x-intercept at 0, and we have another one at 6k. And it's a parabola that opens up. So we don't know how far down it goes, but we don't really care, because what we do know is that that area is going to be equal to 108. So one of the things that we can do to help write an integral for that area is we can draw a representative slice, and because it's vertical, we can label it as x comma x squared minus 6kx, and up here we can label it x comma 0. So we know the area is going to be the accumulation from 0 to 6k on the length of that strip, which is a top y-coordinate minus a bottom y-coordinate, times the thickness. So now if I multiply that out, distribute the negative, I'll get a 6kx minus an x squared. And now I'm ready to answer the question posed by the symbol. We know that this says, what did I take the derivative of with respect to x that gave me the inside? So we would move through the constant, hit the x, we're doing power rule backwards, and we will evaluate from 0 to 6k. Now we know that this evaluation, or the area, needs to be 108. So if I continue, I'll get 108 equals, this says I'm going to plug 6k in first. So I have a 6k times a 6k that has been squared. So that's actually a 6k that has been cubed over 2 minus a 6k that has been cubed over 3. And then I'd subtract what comes out when I plug in 0, which is just 0. Now if I finish this or get a common denominator, I can see here that I need a 3, and here I need a 2. So this one says I have 3 of those 6k cubes minus 2 of those 6k cubes. That's going to give me 1 of those 6k cubes over 6, and that has to equal 108. So if I continue, I will get 6k cubed will be 108 times 6. Well, that is a 2 times a 54, which is a 2 times a 27, times a 2 times a 3. So it looks like I'm getting 1, 2, 3 2's, and this is 3 3's, and a 3 gives me another 4 3's. So I need to take the cube root of that. That will give me a 2 and a 3 and a cube root of 3, and then I need to divide by 6. So I end up with that k equals the cube root of 3. Oh, it's kind of hard to see. I will switch to pens. Okay, so second one, B. B says we have y equals the absolute value this time. So in this case, we're going to think about what an absolute value function is doing as we move it around and graph it. Here I've got a normal absolute value that has been moved k units to the right and then k units down. So if I think about what's happening, that means my normal vertex for the absolute value that used to be at 0, 0 has moved k to the right and then k down. And it still has a side slope of -1 and +1. So here's my region. I want the fourth quadrant. And this one's actually pretty easy because we don't even have to do an integral because it's just a nice pretty triangle. So we can say that that area, which is 108, needs to be 1/2 the base, which is 2 of those k's, times the height, which is 1 of those k's. So that looks like 108 equals k squared. So k would be the square root of that 108, which was a 2 squared times a 3 cubed. So we'll get a 2 times a 3, which is a 6 square root of 3. Next one, C. This one we have a y equals an x cubed minus a kx squared. So this is a cubic graph, which is going to look something like this, and chances are good it's going to dip below the x-axis, which is what we want because we need to have some area in the fourth quadrant. So again, we're interested in when that equals 0, so we can factor, get an x squared times an x minus a k. So I can see that that's going to equal 0 at 0, and then again at k. And that 0 is a double root. So if you remember from last year, when you have double roots, you're going to bounce. We can also see that we've got a leading coefficient that is positive, so that means that cubic shape will eventually head up on the right-hand side. So we can draw a cubic that bounces at 0, 0, and then heads up through here. So now we're looking at this region, and again we know that that area is going to be 108. So I can write this is x and x cubed minus kx squared, and this one will be x comma 0. So I can write that the area, which is 108, will be the accumulation from the x coordinate to the x coordinate, 0 to k, of the length of that strip times the width of the strip. So the length is the top y coordinate minus the bottom y coordinate, and the thickness is dx. Distribute that negative. I'll get a kx squared minus an x cubed. Now do the antiderivative. I will get a kx cubed over 3 minus an x to the 4th over 4, and I'm evaluating from 0 to k. So if I plug in k, I'll get a k to the 4th over 3 minus a k to the 4th over 4, and when I plug in 0, I get nothing. So my goal is to isolate k, so I'm going to get a common denominator here. I've got a 4 and a 4, got a 3 and a 3, so I've got 4k to the 4ths minus 3k to the 4ths. Well, that gives me 1k to the 4th over 12, so I'm going to move that 12 to the other side. We remember that 108 was 2 squared times 3 cubed, and now we got another 3 and another 2 2's because we're multiplying by the 4 and the 3. So if I want the fourth root of that, I'm looking for things that show up 4 times, and it looks like I've got 4 2's and I've got 4 3's. So we end up with k equals 6.